In this video, I'll talk about the measures of position that will be percentile and z-scores for Chapter 3, Statistics 252. Now you're given, of course, a data set, some scores, that's the X, the first column, and then the frequencies. And then you have to compute the mean, which means multiply the value times the frequency and divide by the total number of values, which is the total number, adding up this whole column here to get this, the n right here. In this case, you have 157 values, at least in the data set that's shown here. And now you compute the number scoring below. This is similar to that cumulative frequency. Remember that from Chapter 2? Okay. It's not exactly the same because in cumulative frequency you take the number at that level and below, but here there's a blank here for this one. Right, the number below here is 3, the number below here is 7, and you just keep adding up like that. Number below you would add the 3 and the 4 and the 19, you get 26, which looks like the same number there, but it isn't. Then to that 26 you'd add another 26, which would give you 52. Adding a 25, you get 75, and you continue like that. There's no total here. Actually, the last number will be all the numbers except the 4. So this is the number, the total number scoring below the particular value you're looking at. And from that you calculate the percentile. In the written lecture I discussed that there are many ways to calculate percentiles. Percentile, this is why statistics is a separate branch or separate from mathematics. There are many definitions for percentile, and there's some juggling around in order to get the results that people like. That is, to not have big problems at the top end because you don't want to be at the 120th percentile. That wouldn't make any sense. Okay, so the percentile, what it means, it's the number, well, it's an average of the number scaled to 100, number of people that are scoring below you. And to calculate that number, like I say, there's different ways. You take, according to the book, using the formula there, you take the 3, which is the number below, add the 0.5, which so gives you 3.05. That doesn't looks pretty ignorant. 3.05. Divide by the total number, in this case 157, then multiply by 100. And that will give you the percentile. And you can calculate that throughout that column. Although calculating these percentiles is interesting, I think it's more important to read that discussion in the written lecture notes. And again, I don't want to just see something that came out of Excel. I want to see you do the work, because until you put the pencil to the paper and you actually do some of the work, all you did was push a button. And that's not sufficient. Now in the homework, those same data values are listed again, but their frequencies, instead of being the 3 and the 6 and the 19 and 26 and all that, those frequencies are all changed to 1. So you have to go through now and do the same thing, but instead of computing percentile, you're going to compute z-score. Z-score is very important and it's very precise, unlike percentile. So to fill this in, you have to first calculate, of course, your mean, which is mu. That means you add up all these numbers and divide by however many you have. There'll be more than there's listed here. And that gives you your mean. Then for each data value, you subtract the mean from it to create this column. You square them, and then you add them up. From that, you can calculate first your sigma squared, which would be the sum, x minus mu squared, divided by n, total number that you have that are listed over here. Then you take the square root, and that gives you sigma. That gives you the standard deviation. To find the z-score, it's this column divided by sigma, and that's listed here. Now, it's I think it makes more sense when you look at what actually the z-score does. To do that, let's go back and look at that standard deviation, the bell-shaped curve. So here was the bell-shaped curve, and here was the mean. And then you can see the standard deviation would be here. So for example, your mean could be 19.25 and the standard deviation could be 3.164. The z-score, when you takes all these numbers and rescales it. It rescales it so that the mean turns out to be right at 0. Okay, so your mean is going to be at 0. And the standard deviations become 1. So it takes this and puts it into a standard looking if you want to look here, it just takes it and moves it over here, but it rescales so the sigmas become 1 and the mean becomes 0. And that allows you to do those calculations. That's why all those charts are in the back of the book. If you had finding the area under that curve is what's done in the chapters 4 and 5 and 6. That means how many data values are actually underneath those curves. Finding that out when you have arbitrary sigma and arbitrary mu is difficult. In fact, there is no what's called closed form solution in mathematics. Closed form solution means you've got a formula when you're done with your calculations. There isn't one. That's why we have these tables. Of course, now things are stored on the calculator. But taking those scores, rescaling them into the z-values makes one standard curve. Then you can find the answer there and go back and compare, and then you'll find the results for your particular data set. So that's what's done in these homework assignments, is find the percentile, which again is kind of a fuzzy number being that there's so many ways to calculate it, and then find the z-score. And in doing that, you'll practice again finding the mean, finding variance and standard deviation.